Moving on to a classic state test problem. Find the area of the larger and the smaller squares. So we're given a smaller square, which I have colored in purple, and a larger square, which I've colored in red. So, starting with our smaller purple square, we know that the radius of this circle is 1. So if I go ahead and draw another radius, I know that this will also be a length of 1. Remember, the radius of a circle cannot change. So all that I'm left to find is this side length here. Well, when I drew these radii, they went ahead and bisected the square again. So back up to our last question, we have created another 45, 45, 90 triangle. So I know that the length of this side, or the height of this side, if I'm thinking about the area formula base times height, would be 1 radical 2. That's the 45, 45, 90. The hypotenuse is x radical 2. So for the smaller side, or our smaller square, if I go ahead and try to draw a square here, maybe it'll let me. Okay, good enough. We have 1 radical 2, and we know since this is a square, all sides are going to be 1 radical 2. So area equals base times height. Area equals 1 radical 2 times 1 radical 2. And I could plug this in my calculator. I can do it in my head. I can use some old-fashioned sticks and count them out. Whatever your heart's desire to solve this problem, you will end up with the area is 2. So this is for the smaller square. Now moving on to the larger square. So I'm going to erase my drawings here. And we are now dealing with our red square. So if I know that this radius here was 1, I can go ahead and extend this diagonal because I know that this radius is 1, so the whole entire diagonal there would be 2. Well, let's get some visuals here. If the diameter now of that circle, look at the circle there, that is a diameter because both corners of that square touch. I know that then the diameter going this way would be 2. The diameter going this way would be 2. You can rotate it however you want, but if you notice, our diameter of 2 also touches the larger square. So my diameter is 2, and it touches both sides of the square. So what do I know? Well, my height will always be 2, 2, 2, 2, 2, 2, 2, 2, no matter how many times I move across this square here. And we found that from the diameter of the circle. So if the large square has a base of 2 and a height of 2, because remember squares have 4 congruent sides, I can solve the area as just 2 times 2, which equals 4. So this would be your larger square. So the area of the smaller one was 2. Area of the larger one was 4. Okay, moving on to our next square problem. We're told that the perimeter of a square is 100, we'll just say units, some type of unit. So you take your side length x, 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 because they're all congruent, and to find perimeter, you add up all of the sides, and we are told that equals 100. Well, I can go ahead and combine all of these x's together here to give me 4x equals 100. And then if I solve this for x, it equals 25. So the side lengths now of this square, we know are 25. 25, 25, 25, and a 25. But we want to find the area. So we go back to our reference sheet if we happen to have forgotten, and we say, oh, the formula is area equals base times height. Well, the base is 25, and the height is 25. Plug that into my calculator, and the area equals 625. So that wraps up our practice problems on squares. Let's move on now to rectangles. So thinking back to our hierarchy again, rectangles are also parallelograms. So once again, the formula will be given to you. Area equals base times height. So we see this practice problem over to the side. We're given the height. We're given the base. Area equals base times height. Or area equals 9 times 4, which equals 36. And we were given units here as centimeters. So when we are given units, we write this as centimeters squared. So the area is always your unit and then squared. So that is something to keep in mind as we start moving forward and including different types of units such as centimeters, inches, yards, things of that nature. So our first practice problem says, find the area and find the perimeter of a rectangle with side lengths of 12 and 17. So let me get a drawing here. 12 and 17. We also know that this would be 17 and that side would be 12. So for the perimeter, you add up all of the side lengths together. So we have 12 plus a 17 plus a 12 plus another 17. And when I plug that into my calculator, I get 58. So perimeter is 58. Let me go ahead and solve the area. Remember, this formula will be given to you. Area equals base times height. So I know that my base was 17. My height was 12. So the area equals 204. So perimeter again was 58. We added those side lengths together. Area, we used base times height. And when we multiplied those, that equaled 204. Okay, let's go ahead and find the area and perimeter of the rectangle below. We're given this lovely hint here that says use special right triangles. So we do not know the length, we do not know the width of this rectangle, but we are given a diagonal with a length of 15. We know that since this is a rectangle, that these are 90-degree angles. And then this diagonal, well, it splits through this rectangle here and creates a 30-degree angle. That's what we were told. So thinking back to our knowledge of triangles, they have to add up to 180 degrees. So if this was 90, we're given 30, this remaining angle has to be 60 degrees. And that is what we call a 30, 60, 90 special right triangle. And there are some relationships there. So if our hypotenuse of this new triangle, which I will go ahead and highlight in green, we have this new triangle formed by the diagonal. We then know that with our special right triangles, that this is length 2x, this is x radical 3, and then this is just x. So when I actually plug in the numbers, I have to find x for my hypotenuse. So 2x equals 15, divide by 2, x equals 7.5. So I now know that this side length is 7.5. I also know that this x value is 7.5. So we had to do some back work there just to find our base and height. And now we can go back to the original problem that wants us to find the perimeter and the area for the rectangle. So we have 7.5 radical 3. We also know that this will be 7.5 radical 3. And then if this is 7.5, the other opposite side will be 7.5 as well. So to find the perimeter, we would add all of these together. So 7.5 plus 7.5 radical 3 plus another 7.5 plus another 7.5 radical 3. Friendly word of advice, put this into your calculator. It'll make your life a lot easier because with a couple pushes of a button, you will end up with your perimeter equal to 40.98. And now let me go ahead and find the area, which is base times height. Our base, 7.5 radical 3. Our height, just 7.5. Plug that into your calculator once again, and you get 97.43 as your answer. So with these squares and rectangles, it's very important if you're given diagonals that you think about our special right triangles in those properties.